Hi guys, looking at financial maths, just the amortization formula, which is paying back mortgages basically. Text and test 5 are on page 157. We're going to have a look at questions 1, 2 and 5. Question 1 says calculate the monthly repayments required for a mortgage of €200,000 paid over a 30-year period at an annual interest rate of 6%. So first of all, mortgages, right? Mortgages, pensions, and loans, mathematically, they're all the same thing. They are the sum of the present value of each of the repayments on the mortgage or the loan. The difference between mortgages and loans and pensions is that with a loan or a mortgage, the bank gives you money and you pay it back over, let's say, 10 years. With a pension, you give the bank money or a pension company and they pay you back over 10 years. But mathematically, they're identical. So the question gave us a 6% annual interest rate, but it talks about monthly repayments. So we need to start off by saying, well, what's that as a monthly rate? So you say, well, it needs to be the monthly rate plus 1 compounded 12 times. So as 1.06 is 1 plus r to the power of 12. Solving that, 1.06 to the power of 1/12 is 1 plus r. And then 1.06 to the power of a 12th minus 1 is our rate. Okay, and what we're going to get here is 1.004867. Now I'll just point something out to you. 1.06, in case this happens elsewhere in the exercise. 1.06 to the power of 1/12 is they've rounded wrong. Okay, I'm going to work with this. That's rounded wrong. That should have rounded up to 0.4868. But the book actually has done that and made that mistake with their answers at the back. So just so that the numbers all line up. Most Leaving Cert questions will tell you how many places of decimals to work to. The book occasionally doesn't, and it can cause difference in the a euro or two at the end of a question. So the sum of the present values of each of the payments of the mortgage. So the first payment you're going to make on the mortgage is going to happen after 1 month. So today, the day you get the mortgage, that has a present value of P over 1.004867 to the power of 1 or 1 month. Okay. The next payment you're going to make is in 2 months' time. So that has a present value of 1 plus the interest rate squared. Okay. The next one in 3 months' time, sorry, it's getting a bit messy, is 1.004867 cubed. That's the present value of that. The very last payment you make over 30 years, that's 360 months. Okay, so that's going to be 1.004867 to the power of 360. Okay, that's to 359. That's to 358. So that is the geometric series that represents all of your repayments on the mortgage. Well, what do we have here? We've got a first value on our geometric series of P over 1.004867. We have a common ratio of 1 over 1.004867. That's what you're multiplying by with each step. And we have 360 repayments. So that equation can be rewritten as 200,000 equals, remember, sum of a geometric series formula, a times, 1 minus r to the n over 1 minus r. Okay, so that's for us. A is P over 1.004867 times 1 minus 1 over 1.004867 to the power of 360, all divided by 1 minus 1 over 1.004867. Okay. Now that, when you work that out, you're going to say, well, that's 200,000 equals P multiplied by some number. Okay. Now I should have done this beforehand. In fact, I might pause and do this now.